Hey guys, me again from Smoky Robotics. Today we're going to be talking about Circus again, the progress I made on it. We're going to be talking about this chassis, how it differs, and the similarity it holds with Oswald, my now retired 1 pound bristlebot horizontal. They hold a lot of similarities, but of course there's a couple things different with it, as you can already tell if you've seen Oswald before. This one is a bit wider, and I think it's a bit shorter. I could be wrong on that, but I'll get a comparison going. And yeah, let's just jump right into it. This chassis is made of ABS, just like Oswald's chassis. It's very impact resistant. It can bend quite a bit before snapping. And yeah, it's also kind of all I had on hand. This is all I have, just red ABS. It was a gift, and I print stuff with it because it's easy to print and it turns out pretty nice. So yeah, ABS I think is pretty good for combat robots. I know there's better stuff like nylon, carbon fiber infill, but that's very expensive. I hope to get some of that soon because I know they'll be very durable. And I mean, durability isn't one of the things that Oswald and probably this robot have a lot of, so it'd be nice to have that going for it. So these are the two mocked up robots side by side. This is Oswald. It's just a mock-up. This ain't actually like the real Oswald. It's just, I mean, it's on the motor and stuff, but anyway, it's just for a comparison. You can see that this new chassis has, it's a bit shorter, but also like 3 times as wide, something like that. But yeah, maybe it's only like, maybe like 2.5 or something like that. I don't know, I think it's like 3 times. Yeah, 2.5, I'd say. This is because I wanted to have these two motors, because you're doing a 2-wheel drive instead of a 1-wheel drive. I wanted them to be as close to the weapon as possible. I guess technically I could have them a bit closer, but I wanted them to just be this far to stay safe. Because if you get too close, obviously the weapon's going to cut into the wheel. As you can see right now, it doesn't. I believe I have like a 150 millimeter effective diameter on this weapon. Something like that, 120, 150. I think it's 120 on the ring, and 150 because of the added 15 millimeter tooth. It gives it a 150 millimeter effective diameter. But for this, I could put this quite far out, and obviously I needed a lot of space to put my electronics pile here, and I wanted it to be clear of the weapon because I forgot I just had that locked up on me. It can flex quite a bit, and it has similar effective diameter, so like if I were to flex this enough, it could potentially make contact with something electronics related to like around there. So I kept it further back of it, and the length of like the distance between here and the center of the weapon, like for the wheel, didn't matter as much as it does here, because you want the wheels to be as close up to the weapon as possible. I guess I could have had them like right beside the weapon, but that also hinders its effective range. Right now has like, I think it's like a 270 degree range, like from here all the way to here. If I had the wheels up close, then it would be like that much, and also the wheels would be more exposed. And yeah, all the electronics can go up here, and as you can see, this is raised off the ground quite a bit. Obviously it can pop up, and if it's due to the gyroscopic forces, the front will probably do a wheelie when it turns. That's theoretical. I know when I had the wheels on the bottom, it did tend to do that. The original design actually had these motors on the bottom, which raised it up like even more. But trying to turn one way was like almost impossible to do like quickly, because it would kind of like pop up like that. And if you've ever built a overhead diagonal weapon or like seen one fight, you know what I'm talking about. But when it goes the other way, it pops pops up like that, which I guess would be good. Like if you're hung up on something, you could like turn to one way and then go straight to get off of it, which I did do. Like when I was testing it on the sidewalk, it got off the sidewalk seam by doing that, but also makes it very unstable, and it's just kind of prone to losing control like that. So I put the motors on the top, which makes the weapon more parallel to the floor. It's still not parallel. It has a bit of an angle. I'm not sure how much that would be. Maybe like a 15-degree angle or so. But that's just an estimate. I can't. I don't know for sure. I have to get like a protractor and measure that. But that's pretty. It's not too steep. But we do come like maybe 25 millimeters off the floor. That's how much clearance we have. So it's gonna hit any normal ant weight. It may have trouble hitting like some lower ones, and it has absolutely no ground game. It's very high off the ground, as you can see. And when I had the motors on the bottom, it was even higher. Like any wedge will easily like push this ground up. I mean, if it'll hit like the middle of the wedge, because like it's just so high off the ground, it's gonna get pushed right under and just go along with the ride of the robot. But yeah, no ground game whatsoever. But I mean, obviously that's not what we're going for. We're just going for the weapon. And yeah, quite a lot of space for the electronics. I think this is actually a pretty big ant weight. It takes up quite a bit of a large footprint. This is also a pretty large ant weight, but only in one direction. The other direction is actually pretty thin. But here's like that size difference. Yeah, there it is. The AR weapon has slightly more reach. I don't know if it's enough that it's really that like noticeable and effective, but I think it does have a bit more of range. Let me go check that. So that is 150 millimeters. And let's see, so this, yeah, that's around maybe like 72.5 millimeters. Times 2 is, well, less than 150. So this one has slightly less than that one. And realistically, this probably had even less because it was vibrating, so the tooth was going like, well, I'm not sure if it would bring out or not, but I don't know, the weapon was oscillating, so that definitely affected the effective diameter. It's probably pulling it toward the tooth, but who knows. It's very slight difference. As for the framing, something you may have noticed is we have this strut pattern. This is for a reason. This is for weight savings. It gives us quite a lot of flex. It's a very durable chassis when it comes to flexing. It can take quite a lot. It takes quite a lot of effort to snap one of these. Obviously it can be done. This is only like, this is right here, the solid part is 4 millimeters in height. And I think this part, like right, you can actually see, I don't know if like my camera will be able to catch this. But yeah, there you go. You can see my finger through that. And I believe it's because this is only like 2 layers, I believe. It might be something like that, but it's very thin. Like you can literally see through that. But it should provide some support. This is our motor mount. It's not the most durable thing in the world, but it only broke once in a bot brawl competition against a nasty 2-wheel vertical drum. It actually got a nice hit on the wheel, which the force just snapped it and the wheel went flying. Wheel and the motor were fine, just the motor gave out. But I mean, it works okay. Like it's really light, like it's only like so thick. So I just took that same design, copied it over here, so now we have 2 of those running. And I just have those motors glued in with some hot glue just to keep them in. The motors are going to stay the same, they're nice and light. I'm still trying to find an ESC to drive them. I'm just going to use the same ones as last time, I think. We actually were experimenting with a custom brushed ESC using these cheap H-bridge drivers and a custom microcontroller that we're going to program, but the syncing current of the microcontroller is too weak to pull the side of the signal input to the H-bridge to ground. For some reason they have some very powerful pull-ups on those inputs, so we just couldn't handle it. So we're just gonna go with like these $10 brushed ESCs, and that's what we're going with. But we're just gonna talk about the chassis. So yeah, the motor mount is it's like solid. So we just have this like solid strip right here, and that continues down there, and it's also supported by solid pieces here. So I mean, it's pretty solid down there. I don't think it's gonna break without sustaining a very large impact. This is the only frame I've printed for this yet, and so far it's held up with all my testing, and if you've seen my pavement testing, it's pretty abusive. These can go through a lot of stress, and I mean, it was able to survive that, so I think we'll be good. I will be printing spares of these, of course. Yeah, that's pretty much it. Like, these are pretty light chassis. I think this is only like 25 grams or so, 25-30 grams at the most. It was a little heavier than these. These are like 20 grams. This is a little heavier. It is a little bit more plastic, but ultimately we're going for the lightest chassis we can, and this is like pretty thin on material. And yeah, same wheels. I had lots of spares of these wheels, and I didn't want to have to print more when I had so many of these. I didn't want to waste them, so we're gonna be using these. I have like 2 other spares that I know of. I can probably just dig up more of my junk pile, and we'll find more of those and get those glued up. It still has the same glue treads. Yeah, that's pretty much the chassis. It's pretty simple. I got the little Bob Ross sticker, got those bolts. Oh, I also have this, this is actually a ceramic capacitor. This is what the robot sits on, so that it's not sitting on those bolts. We still have that same aluminum motor mount. These are actually custom. I made them all myself. Pretty easy. Just took a little strip of aluminum, cut it with a bandsaw, and used a guide and drilled out the holes that correspond with the base of the underside of the motor. And then I smoothed it out. I sanded the edges, made it look real nice. And yeah, that's what supports the motor. It's just that one piece on that other side, like it's bolted to the bottom. It holds up pretty good. The chassis will break before that one piece. Like the whole thing will snap off. As experience with Oswald here, the whole chassis will snap in half before any of that like pulls out. So really durable system. Never had an issue with that. And yeah, we have to get some ESCs for this and drive it around. But yeah, I think that's gonna be it for this video. I hope you enjoyed this cheeky footage and me just like showing you stuff on this robot. As far as I know, like the Bob Roll is having some struggles with finding a place to hold their August event. It's the one at the CME has been canceled, unfortunately. It's not happening, so hopefully they'll find one somewhere else. And when it's held, Circus will be sure to fight there, and we will put on a good show. Hopefully we do better than Oswald did. And I mean, it's considering we have 2 wheels and we can actually get away from the wall, I think we might have a decent chance there. So that's where we're at. Hope you all have a good day.